Well, hello everyone. Today is Monday, Memorial Day for us in the United States. I want to give you some updates as to what have I been doing. Been busy last couple of weeks, and on top of that, together with Jay Blantz, again, thank you Jay Blantz, we were working on a little project. Now, you all remember that what balancers did I buy for this for my Powerwall? If you haven't watched those videos, I have those videos before, and also you can watch the battery video and you will know that I'm using 3 cells per module, and those 16 modules make one pack, or a Powerwall as I call it. So today we are discussing how to monitor all of that data. So without further ado, let's continue. So, continuation. I have been using jkbms's to monitor my module voltages, and normally you could only access them on your tablet or on your phone through their little app, right? App is good, app is beautiful, no problem with it, but the only thing is we cannot monitor data over time. It only displays the last value that we have. So the project on hand was to create something that will display this data in Grafana, actually through InfluxDB, meaning it will be stored in a database, and then we can access it to Grafana. So let's get to the next thing and see how does that look after development. So what I have purchased is these balancers. Actually, I did not purchase them from Amazon. I purchased them directly from China, and for better or for worse, they're working. I do have 2 1 amp and one 2 amp balancer. Okay, since they are wireless devices, we know they're going to transmit data somehow. So what project did I work with? Jay Blantz, an excellent guy from New Zealand, does a beautiful job, and I'm truly appreciative of his help. What we did was, whenever this little device transmits data to the tablet, okay, we have managed to trick it into thinking that the Raspberry Pi is your tablet or a phone. Once the data gets onto Raspberry Pi, and it's collected, then what we can do with it is we can show it like this. And we are continuously collecting that data, which can be useful to see what your cells are doing over time. I prefer this look of Batrium. If some of you guys know what Batrium is, I prefer this look when charging or discharging the cells. As you can see, we got all the cell voltages up on top with the total Powerwall voltage, meaning all of these cells from a Powerwall 1 were added together, and that produces your Powerwall voltage on that specific Powerwall. It's not taking the average value of Volt 3 like you would have it through inverters or through any other means. So this is what we have created. This took 3-4 weeks to make. The work is excellent. In the meantime, I have switched to, and then in the meantime of this development, I have switched to an Ubuntu operating system. As you can see, it's not Windows anymore. I decided to do this because it's much more easier to manage, and the operating system is very similar and close to what's on Raspberry Pi. This one does have a graphical user interface and installs on our Intel machines just fine. Ubuntu is a distribution of Linux, so it works good. I can't complain. However, this is the end result. I am going to have module data from all 3 Powerwalls, and in that case we are going to have 48 module data information displayed in Grafana, and we can store it, and then you can manipulate the data. You can watch your cells over time. Why am I doing this? Well, it can help us determine if we do have an issues with our cells, and we can, comparing the data over time, that is the best way to figure out what each individual cell or a module is doing for you. And it can help us see issues incoming instead of just seeing something fail. This is the sole reason from developing this, is to better monitor our equipment. Since we have everything do it yourself, and all of our equipment, for the amount of money that it is pretty good. However, it doesn't have all the fancy stuff for monitoring. So without further ado, let me show you what else I'm working on. But I think this is the fun project and fun update. I think it will serve me well in the long run. And now on to the next thing, which would be working with these little microcontrollers, trying to make some things. I have already managed to test out a couple of things which will help us remotely monitor the battery, the Powerwall temperatures too. It will help us monitor current. This little module together, the ESP32 module together with this INA 219 chip. I'm working on how we can measure higher amounts of current through shunt. This way we will know exactly what's going on with the batteries, what's going on with the state of charge of our Powerwalls. And of course, this little module over here, this microcontroller, is also wireless, has a Bluetooth features, very low power consumption, and they can be incorporated into our databases to monitor all of that, and also have it displayed in Grafana or your choice of visualization software that are available out there. So, little update, nothing special. Just working, playing around while I'm waiting on HOA and attorneys to tell me what's going on with installation of my solar panels. I'll talk to you guys soon. You all have a good one. Safe weekend. We finally, as a family, went to Lake Lanier over here yesterday with the kids, and it was, I gotta tell you, it was packed. But I think everything's coming back to normal. We can only get back to doing our stuff that we did before. Later, guys. Have a good one.